Hello everyone, welcome to my channel Code with Ease. Today we are going to discuss how to check if linked list is palindrome. So, what is a palindrome? A palindrome is basically a set of or a sequence of characters, a word, a phrase, or anything which reads the same backward and forward. So, the most popular example can be race car, the word race car, madam. So, even if you reverse the letters of the word, it's going to read the same in forward or in backward direction. So that is what a palindrome is. In this case, we are given a single linked list which is of size n and it consists of integers, and we have to check if this linked list is a palindrome linked list or not. As we can see in the first example, 1 to 1, yes, it is a palindrome because 1 to 1 being read from forward or backward will be the same sequence of digits. In the second example, however, it is not a palindrome because 1, 2, 3, 4, when we reverse this, it becomes 4, 3, 2, 1, which is not equal to the initial ordering of characters. So in this, we are being given the head as a reference and we have to simply return true or false based on if it is a palindrome or not. And the expected time complexity is linear, the auxiliary space is constant, and it's also given that we should not be using the recursive stack space as well. So yeah, if you are using recursion for this, then we would be using extra space, which we are not allowed to do. So no recursion is allowed in this case. Okay. So with that, let's move to the whiteboard to understand the approach for this. Okay, so first let's define a few integers. Let's say 1, 2, 2 to 1. As we are giving a singly linked list which is consisting of integers only, and that is why I've written 1, 2 to 1. This is a palindrome because it's being the same set of characters forward and backward. So the output for this would be true. Okay, and I'll write another sequence which is not a palindrome, 1, 2, 3, 4. So this case it should be false. What is the expected time complexity? It is linear. Okay, and the space is constant. Okay. So with that, let's first understand what will be the brute force way of solving this question. So as I said, what's a palindrome? It's something that is the same order of characters in whichever direction we are reading. Either it is 1 to 1 from forward or it is 1 to 1 from backward. The most popular one is, firstly, the easiest way to do is using recursion. Apart from that, the simple thing is if we are given a few characters, we just try to reverse it. If we reverse it and then we check it with the original characters, like if it's a string, simple thing is we reverse the string and then we check if it is equal to the original string that we are given. Apart from reversing and recursion, we can also use a two-pointer algorithm, two-pointer technique, in which we start a pointer from here in the beginning, let's say I, and we start a pointer from the back. So if I and j are equal, as long as they are equal, we move forward. I moves forward and j moves backward. So this is another efficient approach that we take to solve palindrome questions. The problem in case of a singly linked list is, firstly, we do not have access to any index position. So even though we know that the head is here, we do not know where the last node is. For determining the last node, we have to do a traversal. Okay, first we have to do a traversal, figure out what is the last node. But even if we figure out the last node in this case, we cannot do a backward traversal because the links are always in unidirection. It's in one direction only. So from 1, we cannot go back to 2. So that will unnecessarily increase the complexity. So optimal way of solving this question would be, if we have a pointer I at the beginning and we also have a pointer j at the last, somehow we have to make this last node in a way so that we can do a backward traversal and we can do a forward traversal from here and we can do a backward traversal from here. If we are able to bring it to that state, then simply by using the two pointers technique, we can do the traversal and we can determine the palindrome nature or not. So for doing that, we have to take a few steps. So let's see what are those steps. Okay, so first let me write about the two-pointer technique that we spoke about. So we are going to use the two-pointer technique at last that we understood, but before reaching to that point, we will have a few steps to be done. So as I was saying that there's a way to determine if something is palindrome or not by reversing it. Let's say I try to reverse some part of this linked list, as in if you guys have not watched how to reverse a linked list, I will link up a related video So as I was saying, if we try to reverse this part of the linked list, so just these two nodes, if we try to reverse, so what happens in case of a reverse linked list? This, let's say, start from here, and these two nodes only I have to reverse. So this node, whatever it is, we start from here, we make this point to null, and then we go over here, and this node will point to this. So this link is broken. 2 and 1, the link is broken between these two. So 2 points to null and 1 points to 2. And in that way, we reach to the node, the last node, and whatever is the last node is being returned back. So this is what happens in case of a reversing a linked list. Whatever was the starting point, that becomes the last node, and whatever was the initial tail node, that becomes the new head node. So if we try to do something of that sort, so what happens? So we will get something like 1 is pointing to 2, and 2 is being pointed by 1. So this is how it will look. This is how it will look after doing the reversal, partly if you are doing the reversal. So once we are able to do this, our problem is solved, because now we can cleanly execute the two pointer technique. We can start one pointer from here, we can start another pointer from here. If we are trying to make this go forward, we are also able to move this one step back, because the links have changed. So it is able to go back. So if it is able to do that, so we can just apply our two pointer technique and able to determine if this linked list is palindrome or not. So now we have figured out that we have to reverse a part of the linked list and we have to apply the two pointers. So we have to reverse and we have to apply two pointer. Now the question remains, as I was saying, I'm going to reverse this part of the linked list. That how do we figure out? That how do we reach to that node, and how do we determine from which node, starting from which node till last, we have to reverse. So for that, what we can use is the middle element, as in figure out the middle element of the linked list. If we are able to figure out the middle element, that will become my starting point, beyond which I have to starting point, and then from then onwards, whatever the rest is, that part I have to reverse. Always remember, the goal is to reverse the links of the nodes such that I can make this j pointer reach here, and if I change the links, then I can simply do the two pointer. So what we have to remember is we have to execute our two pointers. Two pointers require I and j pointers. One will move forward, one will move backward. One will move forward, the one which will move forward, that is very simple because it has to start from the head. But the one which has to move backward, that is the tricky part, because in linked list we cannot do backward traversal. So if we have to make it do a backward traversal, we have to reverse or change the links between the nodes such that finally the j pointer reaches to that node from where I can do a backward traversal. And lastly, how do I understand from which node I have to start? So that is going to give us this middle element. Logic is going to help us figure out the middle element. So this question, as you can understand, is a combination of three concepts. One, middle element of a linked list. Two, reversing a linked list. And finally, the two pointer algorithm. And finally, the two pointer technique. Okay, so with that, now let's see how do we code for this. Okay, so starting with the code changes, first of all, let's first take the current node, which will be equal to head. Then, like we have discussed, we have to find out the last node, and for doing that, we have to reverse it. So I'll say last, and then reverse. I'll call this utility method, which is going to reverse it. But this reverse is going to take the middle. So before that, we have to find out the middle node. So I'll say node mid, in which we have to find out the middle element. And in this, I'll just pass the head. So this middle element, whatever this function is going to return, will go in as a parameter to the reverse. And this is going to give us the last node. After doing this, then we are going to implement the two pointer technique. First, let's try to implement these two utility methods first. First, we're going to implement the reverse method, so which is going to return a node. And this is also taking in the middle node. Now, there are three pointers in total. First will be the pref pointer. Next, it will be the next pointer, which will also be null. And the current will be the one which has come in. The middle element is going to be the starting node for us, so that will be the current. Then we'll start with the while condition, while current is not equal to null. First, we have to take the next node, So the next we have to assign it to wherever the current is, current.next. Then we can make current.next point to the priv pointer, which is initially null. So it is reversed, and then priv can move to wherever current is, and current can move to the next. So this is what is going to happen inside of the while loop. First we are taking the reference of the next node, then we are changing the pointers and making the current point to priv. Then priv moves one step ahead wherever current is, and current moves another one step ahead wherever the next pointer is. So while this is happening, outside of this, whenever the current will reach the null, in fact both next and current will reach null, as we have seen in the dry run. So we have to return the priv. The priv is going to be the new head. So this is priv, this is the node which will be returned, and this new head, what we are saying, is basically nothing but the last node which we needed to have. Okay, next we have to do the implementation for the middle element. So this is also going to return the middle node. So middle element, and then it's the head. So in this we are using the slow and fast pointers. So I'll say first the node slow is pointing to head and even fast is pointing to head. While fast is not equal to null, and fast dot next is also not equal to null. If this is true, then slow pointer will move one step forward, and fast pointer will move two steps forward. Okay, and outside of this loop, wherever slow pointer will be, that we have to return, and that is going to be our middle element. Okay, so that's the implementation for the middle element. So now we have both the utility methods being implemented. So now back to this. So we have the mid, we have the current, and we have the last. And if you have to implement the two pointer, we again have to use this while loop. When is this loop going to break? As you guys might be remembering, when we are trying to reverse this, we have a pointer to the last. And from last, if we go backwards, everything else is also reversed in the backward direction. But if you see, this priv pointer is pointing to null, which means if the middle element, let's consider as that as the starting. So in the middle of the linked list somewhere, some node is pointing to null. Okay. So since that is the thing, so we can say while last is not equal to null, because if it reaches null means that the second half of the linked list has already completed. So till then we can do the traversal. So what we are going to do now, we are going to do the swapping. Okay. So what we will do, not swapping, we are just going to, so now we are going to just check if the current node and the last node are equal or not. So we'll say if current dot data is equal to the last dot data, then both of them will move one step forward. So current will be current dot next, and last will be last dot next, if they are equal. If they are not equal, if this condition, whenever this is not turning out to be true, at that point we can simply return false. Okay, so else we can return false. Outside of this while condition, let's say if this happens and it reaches the null, so if this it comes out of this loop, then we can safely return true, because if anything was not matching, it would have come into this else block and it would have returned false there itself. So we are going to return outside of this. So yeah, that's about this question. Let's try to run this. I'll just check the braces and everything. Okay, let's try to run this. Okay, we'll try to submit. Okay. So this is all about this question, how to check if a linked list is palindrome or not. And do let me know in the comments below if you have any questions or any suggestions. And please don't forget to subscribe to my channel if you guys want to be updated of further content like this. And thank you so much for watching.